Extended reality is often seen as a gimmick and has had some problems expressing its actual usability in professional software solutions. I wanted to see if I could make some tools that really takes advantage of what extended reality has to offer in the context of volumetric visualization. So I made this volumetric rendering of a medical dataset constructed by an MRI scanner. The rendering method is based on a simplified admission absorption method and constructs a model consisting of two materials: an opaque white material defining the data values of interest and a semi-transparent colored material defining the rest. Complex user interface interaction can be a bit clunky in extended reality, so I wanted to make a super simplified transfer function that lets you quickly define your area of interest. It uses two sliders. The first slider, called mid, lets you define a value as the perfectly opaque center value, and a second slider, called width, lets you define the width of the area of data values considered to be of interest. So with this example, let's say we want to view the brain. You start out with a wide range and use the mid slider to find a fitting center value. Then you move between the two sliders, narrowing down the data range while updating the center value until you have reached a good range setting. Getting the data range as narrow as possible removes unwanted noise and heightens the fidelity of the structure you want to view. We often want to examine specific parts of the volume when working with volumetric data. We can remove uninteresting parts of the volume by reshaping the bounding box. If we want to look at the brain, we can cut away the lower part of the head so that only the top is left in view. We can also use the bounding box to cut into the head from any direction. Sometimes the structure we want to see is blocked by a denser structure. I added a density multiplier in my sliders to adjust transparency. We can, for instance, use this to view the brain behind the skull. This does affect the contrast, however, and can make it difficult to see details. I also added a selection of different volume rendering algorithms, but I consider the first one the main algorithm for my application. I do like this X-ray type algorithm though, and I find it useful for some tasks. We can move and rotate the selection easily using our controllers. We can also scale it. This is very intuitive in extended reality and one of the highlights of using it. I wanted to make a search tool that takes advantage of this spatial control, something that would be fiddly to use in a typical two-dimensional application. I came up with this focus tool. You move it around in the volume to look at points of interest. Let's say you want to look at the lungs. You move it into place, then you use the dedicated focus sliders to find a center value and a range that suits your needs. You can use the density slider to remove some of the semi-transparent material. Then you can shape the focus further by using its scale sliders. Maybe you want a flatter disc-like focus, for example, to scan up through the volume. The focus can also be used to cut away dense structures and let you view its inside without lowering the contrast with the density slider. Let's again try to view the brain. Shape the focus so that it cuts away the skull while retaining the brain. Find a good position for the focus and fully gain the density slider. You can see the difference in contrast. You can also cut the focus further using the bounding box. You can also completely remove the surrounding volume if you want, or use a more transparent algorithm on it. focus is very intuitive to move around spatially in extended reality. The alternative is to use a traditional two-dimensional user interface or keyboard and mouse, but this is much more fiddly and not as fast. I also think feel is important, and for moving objects around in a three-dimensional space, not much beats moving your hands around freely. Another advantage of extended reality is the spatial reference. It is much easier to perceive the depth in your visualization when it's constantly moving. The stereoscopic imaging enhances this further, but this you have to try and see for yourself. It is not something that can be shown in a two-dimensional video. So there are some real benefits to extended reality. This was just a short project highlighting a couple of them. There are many more benefits, the most important ones probably still not discovered. It is a fascinating field of research. I hope you enjoyed this video. Bye.